All right. So again, anybody at home, just make sure you know this review sheet, the comprehensive level problems. Make sure you know your trig identities. Like the review sheet, there are a bunch of problems that are just going to test the trig identities. Oh, and what I didn't tell you guys was I'm going to give you the identities for the second part of the test. So I'm going to test you on the first part. So you're going to have 20 questions, 20 points, or whatever. If you don't know your identities, or even know half of them, you've lost a letter grade off the top. Or more, hopefully not more. But I have had people every year that get 4s out of 20 on the identity part. I hope that's none of you, because it's just regurgitating the identities and filling in the blanks. So that's 20 points, but then on the application part, I want you to show me you know how to use them, and that's worth something to me. So I'm going to give you the identities on the very back, so when you get your second part of your test tomorrow, just flip that. If you want to take off the back sheet, I think it's a separate sheet too, you can just tear it. You need to turn it in to me, but you can tear it off and use it to answer any of the other questions, because the other questions are all about application. Y'all with me on that? And you certainly, of course, need to know your unit circle. So the questions I've got so far is, how do you know when you're using a half angle and the half angle identity has a plus or minus in it? How do you know when to use the plus, when to use the minus? Okay, so for example, if I had something like sine of I don't know, how about sine of 450? No, sine of, it's going to be terrible me saying that. How about sine of, I'm trying to use one that I can't. Okay, this is going to be dumb, and I would never use a half angle to solve this. But off the top of my head, this is what I've thought of. Like right here, sine of 240, I would just go to the unit circle and use the unit circle. Okay, so don't hear me that this is the best way to do this, but this will illustrate to you when I would use a plus and when I would use a minus. Isn't it true? Oh, wait a minute, no. How about, why can't I come up with a good example? We'll just use it. Sine of 240. We'll go with it. Okay. So, is it true? Granted, I would never do this, but is it true that sine of 240 is the same thing as sine of 480 over 2? Again, I would not do this. Sine of 240, I'm going to go straight to the unit circle, grab the y value at 240 degrees, and call it a day. Are you with me? But that is a true statement, isn't it? And because of this, I could say, well, that is half of that angle. Well, I can pull out the half angle identity then. And what does the half angle identity say? For sine. And this is something, if you don't know right now, you probably lost a point off the top of your test. Every time you don't know one, boom, boom. What is that half angle identity? It says, the identity says plus or minus. But really, I have to answer the question, is it plus or is it minus? So you can put it there for now, but in a second, I need to answer this question. And the identity says what? 1 minus the cosine of that angle all over 2. Okay? Now, at this point, I would have to simplify this. But before that, I got to decide, is this plus or is it minus? So what I do is I go back to the original problem. Okay? I go back to the original problem and I go, wait a minute, 240 is over here in this quadrant. And I know that sine is positive in the first and second, negative in the third and the fourth. So I know that this should be a negative value, shouldn't it? So that tells me, based on the original sine of 240, that this has to end up being negative. Now you know that because this answer is going to end up being what here? Again, I would never have done it this way, but what is this answer going to end up being? Negative square root of 3 over 2. I know that. So you can see, I already know it's negative square root of 3 over 2. Well, that's what I have to end up with. If I put plus or minus, that's telling me my answer is going to be plus or minus square root of 3 over 2, and that's not right. So I have to decide when it's negative, when it's positive. Now, to simplify this, I would probably just subtract the 360, and then I would say, what's the cosine of 120 there? And what is the cosine of 120? Negative a half, left a half. And what's 1 minus a negative? If I had that, I would probably multiply the top and the bottom by a 2. And if I do that, I get 2 plus 1 over 4, or 3/4, which is negative square root of 3 over 2. Now that's a very long, ugly way of going about this problem, but I hope that I'm illustrating to you the idea of how do you decide if it's plus or minus. And why I'm having a brain fart, I'm picking a number that you can't, but anyway, I don't know, it's early. But that's the idea on it. So if you ever see a situation, even if I start you with something like this, okay, if you see something like that, here's a great one with cosine. How about this? Cosine. What if I were to start you with this? 210 over 2, which is what, 105? Now there are other ways to do a cosine of 105, right? I could use a 45 plus 60. It could give me that. But if I was using a half angle, cosine of 105, isn't that the same thing as 210 divided by 2? If that's the same thing as 210 divided by 2, then the only difference here would be what on this formula? The cosine half angle formula would be plus there. I would carry the 210 over, and I would be solving this. But again, I got to decide, is this positive or is it negative? So I don't look at 210 over 2. I go back and say, well, what would 105? What would that look like if I was simplifying or taking the cosine of an angle like that? Well, you know cosine's positive here and here, right? So 105 in the second would mean it would have to be negative. So you come in here and you choose negative. And then you go about the process of simplifying. Yes, no? So that's a better example of maybe when I would use this half angle. Now, if you look at that and you go, oh, well, I would much rather do a 60 plus 40. That gives me 105, and then I can use my alpha plus beta identity. Knock yourself out. I would probably rather do it this way as well. Now, there's a chance, and I have done this in the past, that on tests, I'll come in here and say, hey, you make sure you, and I'll tell you in the problem, use the half angle identity to solve this. Well, then I'm tying your hands, right? I'm forcing you to do this. If I don't say, though, you do whatever you want. Now, I may or may not have mentioned this before, but when it comes to tangent, you have a bunch of identities, right? For half angle. So if I give you something like tangent of 105, you have the choice of saying, oh, well, I could take half of a 210 and use a half angle identity, or I could say tangent of something like 45 plus 60. Which one would you like to use, do you think? Man, the half angle is so much easier. And I think I've mentioned that once before. The half angle identity, because there's 3 of them, you can avoid the plus or minus one completely. Right? The one that has the square root of junk over junk. Just avoid that. And which one did I say was really easy and really nice and it was my favorite?
Sine beta over 1 plus cosine theta?
It's the 1 minus the cosine theta over the sine theta. So I'm going to use the 1 minus the cosine theta over the sine theta. And now I don't have to think about the plus or minus or whether it is. I don't. And more than likely, I'm going to get a really clean answer that's just 3 parts. That's a monomial, right? What's sine of 210 degrees? It ends up being a half. And look how simple cosine of 210 ends up being negative square root of 3 over 2. And this simplifies, if I multiply the top and the bottom by a 2, 2 plus root 3 over 1, and I'm done. But if I do an alpha plus beta identity, look at the math on this. You have tangent 45 plus tangent 60, 1 minus tan 45 tan 60. And now I've got 1 plus root 3 over 1 minus 1 times root 3, and I've got to rationalize. And this is a good one. Sometimes I have root 3 over 3 where I have to get rid of fractions, then I have to rationalize, then I have to simplify. This takes multiple steps, whereas this is like bada bing, bada boom, and you're done. Are you with me on that? So if you ever have the option of half angles or alpha plus betas, I always go with half angles with tangent because they simplify better. That's assuming I'm going to use that identity. And I go with alpha plus betas for sine and cosine because, in my opinion, they simplify a little bit better. And that's the majority of the time. All right. Also, I want to mention this, and then I'll go back to this thing. If you're dealing with trig identities, you'll notice all the trig identities I gave you were all sine, cosine, tangent, and they're random functions. You'll notice I didn't give you secant, cosecant, cotangent. That doesn't mean they don't exist. So if I asked you, what is a cotangent half angle identity, what are you going to tell me? Flip a tangent identity. Now there are 3 tangent identities. My favorite tangent identity, half angle tangent, is this one. Is the 1 minus the cosine theta over the sine theta. And it's my favorite because it has a monomial on the bottom. But if I want to do this, and I flip this, that's fine, but what do I now have on the bottom? A binomial, which means I'm probably going to have to rationalize that denominator with a conjugate. It's more math for me. However, since I also have this as an identity, to me, for a cotangent, I'm going to be in much better shape flipping that. Is that making any sense? But again, it's your call. You choosing a different identity is just going to take you a little bit longer. It's not going to be substantially harder, just a little bit harder. So if I gave you that, don't look at that and go, oh my gosh, he didn't give us that identity. I thought it was supposed to be 1 minus on the top. What the heck is 1 plus on the top? You're right, I didn't give that to you. But I did give you this. So if you recognize that as a half angle tangent, then what would the reciprocal of it be? A half angle cotangent. So that's what you have to know. Are you with me? So if you see something like this, which I think I actually gave you on this quiz, if you see something like what's 1 plus cosine theta over 1 minus cosine theta, don't look at this and go, wait a minute, does not exist. Don't say that. This identity was not given to you, but the reciprocal was a half angle tangent, right? What does that make this? Half angle cotangent. Tracking with me? Or if you were to see this, what is that? The reciprocal would be a half angle cosine, right? So if that's the reciprocal of a half angle cosine, then this is going to be a half angle secant. And if you're wondering about some of my keys have absolute value on them, you know why I do that? I may or may not have mentioned this. I forget what I've done. Right there, when you're normally writing the identity out, you normally are starting with something like cotangent, right? Or tangent. And you go, well, it could be either the positive or the negative. You have to decide. But if I've already decided, if I tell you, hey, it's the positive, and I write this, is there a chance that that gives me a negative number? Well, I can't have that. So if there's a chance it can be negative, I got to go, wait a minute, it's true, secant sometimes is negative, right? Sometimes it's negative negative in the second or third quadrant. How do I know that my theta over 2 is not in the second or the third? So if I've already decided, hey, it's positive, because I've put a plus there, how do I make sure this is positive? Oh, just do that. And in years past, I probably don't take off for you forgetting the absolute value, but I normally give a bonus point for you remembering it. So, yeah.
What if you say it's negative?
So if it's negative, it's a good question. If it's negative, and again, I'm not going to take off for this, but if it was negative, even plus or minus, here if it's negative, I'm saying, wait a minute, I want it to be negative. How do I make sure this is negative? Now you may go, oh, we'll put a minus on it. Does that really make sure it's negative? Because what if that's negative? Now what did I just do? I made it positive. So how do I make sure it's negative? Good. You put the absolute value to go, all right, it's positive, and now I'm making it negative. But again, I'm not, this test to me is not about that kind of weirdness. So if I happen to do that, and I used to do it like, you see it even on this quiz. Like right here, you see a plus or minus. I don't even know if it's right on my key. But right here, I put the plus or minus there. That technically is what kind of identity? Look at it. It's not the tangent, is it? Tangent would be minus and plus. This is the cotangent half angle. But this is saying, hey, this is technically saying I want the answers to be both plus and minus. What? How do I make sure it's both plus and minus this time? Because that's either going to be positive or going to be negative, depending on the theta. So technically, you would have to do this. But I'm not worrying about that. So if you put cotangent of theta over 2, that's fine. But if you remember the absolute value to make it exact, then I usually give you a bonus point throughout the test when you do that. It might show up a couple times. And then lastly, this was the problem. I omitted on the last test. And let me just find some space. Okay. Okay, so what if, and you have to be able to do this. I'm telling you, it's going to be a, and then I'll talk about triple angle. It's going to be a question on your test. So what if I said, what is the, I don't know, whatever, the tangent of the inverse sine of 2/3 minus the inverse cosine of negative 12/13. Now you have to know how to do this. Now somebody tell me, what does the inverse sine of 2/3, if you were able to do that, what would you be getting out of that? An angle. That's what you really should know at this point. That an inverse sine of a value, right? Because you always trig function angles and you inverse trig function values. So the inverse trig function of that value is going to give me an angle, which means this whole thing right here represents that theta or alpha or whatever. I have no idea what it is. I will never know what it is without a calculator. I just don't, that's not a unit circle value. But I do know that all of this right here represents some angle. And same thing with this. I have no idea what that is because that is not a unit circle value. So I can't find it. But I do know that it represents some other angle. So what I technically have here is a tangent of an alpha minus beta identity. Right? And if I have a tangent of an alpha minus beta, what identity do you guys use? Tangent of the what? Alpha minus tangent of the beta over 1 plus tangent of the alpha times tangent of the beta. And that's my identity. Except I can't put alphas and betas in there. I can't put the letter alpha and the letter beta. What do I put? That. So I put that alpha, inverse sine of 2/3, there and there. And I put that beta, inverse cosine of negative 12/13, there and there. And then hopefully you remember this from the last test. Because on the last test I gave you problems like tangent of inverse sine of 2/3. And what did you do when you had a situation like that on the last test? You drew a triangle, right? Now, is it important where you draw that triangle? Can I just do this? And label it up?
Yes.
Can't. No, I can't on this one. Because this sine, this inverse sine is positive. And inverse sine positive shows up between here and here. And if it's positive, it's in that quadrant. So I got lucky. So when I label this triangle, here's my alpha. That's the angle that this stands for. And when I label it, I go opposite over hypotenuse. This Pythagorean theorem gives me a root 5 right there. Everybody good on getting that root 5? Now, I'll never know that angle. Remember, I'll never know the alpha. But I don't have to. Because all I have to do is find the tangent of it. And what is the tangent of that alpha? 2 over root 5. Okay, so that whole expression, that whole thing is 2 over root 5. And then I gotta do the same thing again, but here, again, if you draw this picture incorrectly, you stand a chance on missing stuff. Because I need to draw it like, wait a minute, if I just do this and go, oh yeah, 12 thirteenths, oh, I guess it's negative. I mean, I may or may not get lucky on this thing, but that's not where this picture is. How do I draw an inverse cosine? Where does inverse cosine exist? 0 to 180? And it's negative. So where do I have to draw it? Second quadrant? And then when I label that, I go adjacent over hypotenuse. And then I have a what? Isn't that 5? 5, 12, 13, Pythagorean triple. Right? And it's positive because it's going up. And it's important that you see that because I may be asking you to use one of these signs. But now that is my beta. So all I have to do now is take the tangent of that beta, which gives me negative 5/12. Are y'all seeing this? And then once I have those two, I'm kind of home free because I'm just going to reuse them. Negative 5/12. Sorry. Negative 5/12, and it's already minus. Sorry. So minus a negative 5/12. Y'all seeing this? And then if you get that set up, that's half your problem, if not more. Maybe the last part's just cleaning it up. What would you do with this ugly fraction inside of a fraction? Multiply by what? What did 12 root 5 do it? Let's see. 12 root 5 on the top. 12 root 5 on the bottom. If I multiply that into that, the root 5s cancel, leaving me a 24. 2 negatives is a positive. If I multiply that by that, the 12s cancel, leaving me 5 root 5. Looks good so far. If I multiply by 12 root 5 times the 1, I get a 12 root 5, and a 12 root 5 times that, all of it cancels, leaving me a minus 10. And at least I got rid of the fractions, and now, sadly, I would have to do what? Rationalize. And if you're going, are you going to do that to us? It's possible, but usually on problems that have half angle tangent, I'm a little bit kinder. I'm sorry, when I have a tangent element plus beta, I'm a little bit kinder, and I'll probably make these all Pythagorean triples just to ease pain and suffering. Y'all with me? And then the last thing you really need to know, not the last thing, but another thing that somebody asked about was triple angles. You have to know your triple angle identities. And listen, they don't show up a lot. A lot of times they're not even in pre-cal textbooks. I don't know if they're in yours or not, honestly. But the triple angle identities are similar to the, y'all, did I do a proof for y'all? I did? Okay, so it's in a video. So the triple angle identity, if I remember correctly, is 3 sine of theta minus 4 sine cubed of theta. That's the triple angle, has a cubed, not a 3 in front. And don't go sine of 3 theta here. That wouldn't make sense, right? Sine of 3 theta equals sine of 3 theta minus stuff. It's like saying 12 equals 12 minus stuff. Doesn't even make sense. So 3 theta, 3 sine theta, cubed theta. And then what is the cosine of 3 theta? You just flip-flop those, but make them cosines. I don't know if you noticed that. So just change the order and then replace them with cosines, and you'll have your triple angle cosine. And how would you use something like this? What if I had asked you, I don't know, what about, I think I've done this one a number of times. 3 sine 10 minus 4 sine cubed 10. And you look at it and you go, oh my gosh, triple angle cosine, right? So you say, well, that's just the sine of 3 times that angle. And 3 times that angle is 30, and sine of 30 is a half, based on our unit circle. And if I uglied it up a little bit, how would I ugly it up? I guess I've done this already a couple times. Put a 5 in there. So now when you triple angle the 5, you get sine of 15, which is not 1/2. Where would you go from there? Are you finished?
Sine alpha minus beta.
So you could go a little further. You could do a half angle. You could do a sine of a 30/2. Although that gives you that square root formula. It's not super fun. You could do a sine of like 45 minus 30. You're going to get a problem like that where you have to use the alpha minus beta. And then that would be pretty easy to go sine alpha cosine beta minus cosine alpha sine beta. Simplify that. You tracking with me? All right. I gotta be honest, I'm a little worried about the identity part for you guys, because you've actually never taken a trig identity quiz. And most people, when they come in here, have taken 10 at this point, 6 last year, 4 this year, and you had summer reading quizzes, which you guys didn't have, that had them all over the place. So most people have been studying these identities since last spring, most people in this class. But because of our circumstances, it's just not been that way. But I put those quizzes on there. There's 4 of them. I would at least take the last 2 just to kind of see. And if you're missing anything, make flashcards. Get out some index cards or some envelopes or whatever works for you. And make some flashcards and really practice them. And make sure you're in good shape. Anybody else on anything?
I got a problem with my algebra on like 27. I'm starting with that, and I don't get how you get rid of the retail bottom.
Okay.
I need to have.
Cosine of pi over 12? Let's just do that because I like what you're doing on that. All right, so his question was about cosine. What number was this?
27.
So this is number 27 on your review. Cosine of pi over 12. And a lot of people shy away from these. It freaks them out. They're like, pi over 12, that's not on the unit circle. I don't even recognize pi over 12. It bothers me. So they change it to degrees. And there's nothing wrong with that. If you want to change it to degrees, there's your degrees. And at that point, you can use a cosine of 30/2. Did I say to use a half angle?
No.
So at this point, I could say, oh, well, that's cosine, of 45 minus 30. Or you could say that's cosine of 30/2. And that's fine. You can use either of these identities to simplify this. You'll actually get a slightly different answer when it looks different, but it's the same thing. So like this one will be like a radical plus a radical over a 4 or something like that. And this will be like the square root of something. And then I'll answer a question in a second. But guys, you don't have to do this. Do this. Take your cosine of pi over 12 and do this whenever you see a 12 or an 8, something that is a multiple of, you know how the unit circle values you have are like pi over 3, pi over 6, pi over 4, right? So you only see the 2, 3, 4, 6. If you ever see something like that, like an 8 or a 12, think about it like this. This is pi over 6 times 2. Sorry. This is cosine of pi over 6 times 2. So this is cosine of pi over 6 halves. That's all you got to do. So cosine of pi over 6 halves. And if you do that, pi over 6 is 30, and you've skipped all this junk and this risk of maybe multiplying or dividing incorrectly. So that's pi over 6. That's a half angle cosine. Now his question was, when I'm pulling out my half angle cosine question, all right, 1 plus cosine of that at new angle. And by the way, pi over 12, what quadrant would that be in? First quadrant. And you may go, how do I know that? Well, it's smaller than pi over 6, and pi over 6 is in the first. So it's still in the first, and everything's positive in the first, so I go with positive. That's the choice you have to make. It's not plus or minus, it's you choose. So that's positive based on the original question that had been asked. Okay, now if that was cosine of 11 pi over 12, 11 pi over 12 is near what? It's right near pi. That's in the second quadrant. Cosine would be negative there, wouldn't it? So I would go with negative. But this one's in the first quadrant, so I go with positive. Now, right here, he said, what do you do when you have cosine of pi over 6? Cosine of pi over 6 is square root of 3 over 2. How do I go from, what do I do from here? Well, this is one of those fraction within a fraction questions. And whenever I have a fraction within a fraction, I look at all three numbers, 1 over 1, 2 over 1, and root 3 over 2, and say, what's the common denominator? And it's 2, so I'm going to multiply the top and the bottom by a 2. And when I multiply that in, I get 2 plus root 3 over a 4. Don't cancel that, it doesn't cancel. Right? It gives you 4. All of that's under the radical, and that ends up, I can't simplify the top very easily, but I can take the square root of the 4. So that's what I would do. But if I use an alpha plus beta, I'm going to get a different looking answer than this. It's going to be something like root 6 plus root 2 over 4. But if I type them in my calculator, you'd see the decimals were the same. They mean the same thing, they just look different because you're using a different approach. And technically there are ways to simplify this, we're just not getting into it. Anybody else? No one? All right. See if anybody emailed me. And that is a no. All right. Well, I'm going to let you do your thing for the next 10 minutes or so. And if you got any last minute questions, try to get them to me before I head out of here today if you have the free time to look at this, or hopefully you've been playing around with it a little bit already. And again, if you don't know those identities, make sure you're studying.